Hello everyone, I'm Sam from the Lai Chili Intelligent Maintenance Service Team, and welcome to Episode 8 of Series 2. The last few episodes were all about the stacker itself, from rails to addressing to the forks. Today we cover a linking element, the input/output station. What is a station? Simply put, it's the interface between the AS/LARS and the external conveyor. The stacker retrieves a load and sets it on the station for the conveyor to carry away. Or, the other way, the conveyor brings a load to the station for the stacker to pick up. Note that if a station isn't well calibrated, not level, worn rollers, misset sensors, goods will jam, misalign, or even fall. So this episode covers station maintenance and calibration. 4 learning goals today. First, understand the station structure, the types of I/O station, and what they're made of. Second, learn leveling, how to measure and adjust the station's height and levelness. Third, master daily maintenance of rollers and chains. Fourth, learn to troubleshoot common station faults, jams, misalignment, dropped loads. Let's look at station types and structure. There are 4 main types. The single station is simplest, we deal one pallet at a time. The dual station is more efficient, handling one in and one out at once. The RGV dock interfaces with the shuttle and has locating slocking. The conveyor dock connects to the main line with accumulation. Whatever the type, the core parts are similar: the station frame, the roller or chain conveying surface, guide and positioning devices, detection sensors, and the power transmission. In short, station accuracy directly affects the stacker's pick-put success rate. Now the station's power transmission maintenance. It comprises the motor, gearbox, and coupling. What to watch in routine checks. First, whether the running current is balanced. The 3-phase difference should be within 10% and the casing temperature no more than ambient plus 40 degrees. Check the gearbox oil level. And for leaks quarterly. The coupling is the key link between motor and gearbox. Check its alignment every 6 months. Radial offset within 0.05 millimeters, angular within 0.05 millimeters per meter. What does that spec mean? It means the motor shaft and gearbox shaft must line up very precisely. Common issues include a worn coupling element causing noise, an aged gearbox oil seal leaking, and motor overload. A special reminder: act on motor bearing noise promptly, or a failed bearing can let the rotor rub the stator and burn out the motor. Let's look at the leveling steps, in 4 parts. Step 1, set the datum. Use the stacker's fork as reference to set the target station height. Step 2, measure height, place a straight edge on the rollers, and use a level to find the deviation. Step 3, measure levelness, 3 points each in the longitudinal and lateral directions. Longitudinal within plus or minus 2 millimeters per meter, lateral within plus or minus 1 millimeters per meter. Step 4, adjust via the base adjusting bolts and stainless shims. What's easily overlooked? For one, the station height must match the fork. A gap over plus or minus 3 millimeters causes jams. Longitudinal level matters more than lateral. As the roller coating wears, the real height drops and must be compensated. Foundation settlement also shifts the height. Finally, the mantra: height first, then level, then centering. Now roller and chain maintenance. Roller care has 4 parts. 1. Turn each roller by hand monthly to check it's free. If it won't turn, the bearing has seized. 2. Check the coating thickness quarterly. Replace it if worn beyond 3 millimeters or if it's peeling. 3. Measure roller levelness monthly. Replace a bent roller. 4. Check the sprocket and chain monthly. Replace the chain if it has elongated more than 3%, and replace the sprocket together with it. As for the drive chain, keep tension right, lubricate monthly, and check it once on any noise or judder. For example, if one roller seizes and stops turning, its coating eventually wears flat and goods jam there and can't get out. Now guide and positioning device maintenance, the parts that ensure a pallet enters the station accurately. Check the guide rail monthly for straightness and wear and SRAM. Replace it if worn deeper than 1 millimeters. Keep guide railers turning freely. Deal with seizing promptly. A loose or worn locating stop affects where the pallet stops. Replace a locating pin / when the clearance exceeds 0.5 millimeters. How to check positioning accuracy. Mark the pallet's corners. Simulate 3 in-out cycles, and measure the stop position deviation each time. The tolerance is within plus or minus 5 mm fore aft, and plus or minus 3 mm side to side. Note that the guides are key to station life. Poor guidance lets the pallet strike the station, which in turn damages rollers, sensors, even the frame. Now the station's electrical inspection, covering 5 areas. Check the motor power wiring monthly for looseness and measure insulation resistance. It should be no less than 1 meltons. Check sensor cables for water in the connectors and damaged sheathing. Check the PLC/I/O module's LEDs quarterly. If an alarm LED is on, read the fault code. Blow out the cabinet regularly to keep it cool. Test the e-stop and safety loop daily. What are the common electrical issues? Loose motor wiring can cause phase loss and burn the motor. Sensor signal interference is usually from poor shield grounding, and a PLC module must be swapped with the power off. For electrical troubleshooting, remember 3 steps: LEDs, wiring, module, and finally, power off. Before working, safety first. Now let's focus on station sensor calibration. There are 4 main sensor types. 1. Load detection, a photoelectric sensor. Clean its lens and test its function monthly. 2. Position detection, a proximity switch, or photoelectric. It checks whether the pallet has reached the right spot, so check its trigger position monthly. 3. Profile detection, a light curtain or through beam. It checks for over height, over width, or skew. 4. Safety interlocks, a door switch or light grid that stops the machine when someone enters the area. Note this figure. Sensors account for 60% of station faults, and 80% of those are caused by dirt. In other words, cleaning is more effective than replacing the sensor. Now centering and gap calibration, in 4 steps. Step 1. Set the datum (ballerie). Use the fork center line as reference and mark the station center line. Step 2. Width centering. Measure the center to guide distance on each side. Side deviation within plus or minus 2 mm. Step 3. Depth centering. Ensure ample fork stroke. Step 4. Verify by running a loaded cycle with the stacker. What's the gap spec? The gap between station and conveyor must be no more than 3 mm, with a height step within plus or minus 2 mm. The bridge plate must be sound and fixed, with no step. Note that poor centering or a bad gap leads directly to jams, tilting, even dropped loads. So check the gap monthly. Now troubleshooting common station faults. There are 5. 1. Pallet jams. First measure the height gap between station and fork, then check whether the rollers turn. 2. Pallet doesn't reach position. Clean the sensor first, then recalibrate. 3. Skewed entry. Measure levelness, and check roller wear. 4. Dropped load. Adjust the station height and fit a bridge plate. 5. Conveyor noise. Lubricate the chain. Replace the bearing. How to remember the order. Sensor first, then height, then mechanics. The daily checklist is quick. Listen, check LEDs, turn the rollers, run a pallet. Remember, the station is a heavily used area, wearing 2 to 3 times faster than the stacker, so monthly checks are essential. Now the daily inspection and maintenance schedule, in 4 tiers. Daily test the e-stop, check sensor LEDs, listen for noise, watch the pallet flow. Weekly clean the sensor lenses, check cables, turn the rollers by hand, check the anchor bolts. Monthly measure levelness and height. Test, calibrate the sensors. Check motor current and temperature rise. Check guide wear. Quarterly measure coating thickness, check chain tension and elongation, check gearbox oil, clean and tighten the cabinet. Annual maintenance includes coupling alignment, bearing replacement, a full accuracy recheck and insulation testing. One thing to stress: record keeping, log the data every time, and build a trend chart so the data can foresee problems. Here's a real case. An inbound station began jamming after 2 years. MCALT, a pallet leading edges caught at the entrance. What was the cause? The entrance turned out to be 8 mm lower than the conveyor. The anchor bolts had loosened, and under long-term vibration, the frame had tilted and sunk. Luckily, there were history records showing the deviation worsening from 1 mm at installation to 4 mm after a year and 8 mm after 2. So we retightened the bolts and shimmed the height back, and it returned to normal. The lesson: station height is not a set and forget job. Measure it monthly and build a trend so you catch drift early. Finally, let's recap today's 6 key points. 1. The station is the stacker's docking interface. Its accuracy directly affects throughput. 2. The calibration mantra: height first, then level, then centering. 3. Sensors account for 60% of station faults, 80% of which are from dirt, so clean before replacing. 4. Replace worn rollers promptly. A coating worn beyond 3 mm or a seized roller causes jams. 5. Keep a height measurement history. Only data reveals the trend. 6. Stations wear 2 to 3 times faster than the stacker, so maintain them more often. Got it? That's it for today. We covered station types and structure, leveling methods, roller and chain maintenance, sensor calibration, common fault troubleshooting, and a case of station height drift. What's next? 5 early signs of stacker accuracy loss and how to prevent them, helping you catch problems before they actually become faults. And before we sign off, let me give you a brief business introduction. Our Lechelle, Vietnam team specializes in logistics automation equipment maintenance services for Vietnamese companies, and we have a fully localized professional service team. If you ever need maintenance services, feel free to contact us anytime. Thanks everyone, see you next time.